Hi, everyone. Thanks, Sarah, for the introduction and the opportunity to present today. I'm pretty happy to see the number of interested people in the topic, which is near and dear to our hearts, which is assessing culverts for fish passage, and this will be a bit of an introduction. The Nova Scotia Salmon Association's NSLC Upstream program is primarily geared to helping community groups restore aquatic habitat. We provide funding and training and technical support. And one of the kind of low-hanging fruit, or the key things we try to do is ensure that there's access to habitat, and that way the fish can decide where it is they need to be when, and have the best chance of increasing their populations and improving productivity overall. That being said, sometimes allowing access or increasing access for habitat can be a challenge. And so since about 2010, we've been developing an aquatic connectivity program when sort of a happy serendipity of both interest and resources aligned for us. In particular, we had a corporate sponsorship with the Nova Scotia Liquor Corporation, which began then and continues now, which provided us with increased capacity and resources to be able to pursue this investigation and training opportunities. And there were some very active and keen partners ready to get involved. The Clean Annapolis River Project had been working on this, on assessing stream crossings in their watershed for a couple of years through their very excellent project called Broken Brooks. And also in sort of the same geographical area is the Mersey-Tobiatic Research Institute, who was collaborating with Parks Canada and Kedji National Park on aquatic connectivity. And so together we got talking about how to develop protocols and develop materials and a training curriculum so that more groups would be able to assess their culverts and determine how connected or disconnected their habitats were for their local watersheds. What this talk will do is sort of give an introduction to aquatic connectivity and the ways in which culverts cause problems. There's been a certain amount of assessment of culverts, many jurisdictions across North America and here in the Maritimes. And pretty consistently we find that culverts, about 60% of them are barriers to fish passage, either all the time or some of the time. And so when you think about the road networks that we have, and also rails, that's a lot of stream crossings and a lot of opportunity for lost habitat when 60% of them fail to pass fish. So how disconnected habitat is depends a little bit on where the road crossings are and how much habitat they're cutting off. Oops. Sorry about that. I always do that with slides. So you can get something that's quite open and the fish can get anywhere it wants to. And so examples would be free passage for a culvert where there's no kinds of outflow drops, it's well backwater, there's a natural bottom, and there's no velocity barrier. You get fragmented habitats which cut off habitat to different degrees and are of varying concerns. When we get to barriers to fish habitat, a key one is often inadequate water depth during periods when they're migrating. People really think about anadromous fish, which are when they're trying to migrate up to their spawning habitats, and that is a key time. But there's also the concern of migration within seasonal migration as fish look for the habitat requirements they need, and in particular cool water, for example, for trout, which studies have shown that trout will swim great distances even in the course of a day and certainly in a season as they search out the optimum conditions for themselves. Another barrier is excessive water velocities, and they're not always obvious, but each fish has a certain ability to swim a certain distance against a certain current, and if they can't make it, they won't get through the culverts, and that is increasingly becomes a problem. More obvious for a barrier are outflow drops. You see hung culverts, and that's obviously a barrier, and you can tell just by looking they're not going to pass fish. The picture on the right, on the left is really obvious, whereas the one on the left is just a little outflow drop, which maybe you think, oh, a fish could swim, except that when you get looking in that culvert, you can see there's not very much water flowing through that. Another problem for fish passage is just simply deterioration when they're rotten culverts and their water flows through and under them. And also incorrect sizing when we have either a very shallow water or, again, the velocity barriers pushing through. Another pretty common barrier is just debris blockage, and that's actually the simplest of all things to fix if anybody identifies the problem and can clear it out again, and you get sort of instant gratification of fish being able to access the habitat above. And it's more common than we think and is an opportunity for people to really make a difference in their watersheds. So as I mentioned, there are with our road system, there's a lot of potential for road crossings, a lot of potential for barriers. And so part of what we find is you need to be able to prioritize what part of your watershed you're going to look for culverts, and then which part you're going to prioritize for assessing them. In the Annapolis watershed, for example, where CARP did their Broken Brooks project, they had found more than 2,000 culverts. And then they've assessed a lot of them, but they really had to prioritize how they're going to go about doing that. So there's some recommendations for doing that. One is to start at the closest end of the main arteries, but also to consider how much habitat can be gained. So you might look at this little map on the screen and consider which culvert is the highest priority and which might be the lowest for you. So where I've circled there is probably the culvert that's the farthest down in the system. You can see that it's coming up. And this little one over there is obviously a less priority because it's just a small amount of habitat being cut off. These are sort of the conditions under which a non-baffle culvert, meaning just a regular culvert that's less than 25 meters, is going to be either a barrier, a partial barrier, or a full barrier. And really the key things that we look for are the slope of the culvert and whether or not there's an outflow drop. That being said, when we go through some of the assessments, you'll see there's other considerations. So what I'd like to talk about is about the data collection that we recommend when we're doing training for culvert assessments, and to sort of have and part of what I'm going to do with this as a sort of an introduction is have a look at the data sheet that we do, and then look at each part of it and to consider what it is a person is assessing for, and really to give a sense of why you're doing the different parameters. What we've really found is that it's not enough just to look at the culvert. You actually need to assess it properly. So just by way, I'm going to run through the equipment that's needed in order for doing a culvert assessment. There's obvious things that are needed in terms of materials you need on hand for recording data, clipboard, data sheets, general things. Having a GPS is important so you can find that culvert again. Another really important one is a camera, and I'm going to spend a little bit of time talking about how important images are. And the other thing you really have to do to know whether your culvert is passing fish or not is to actually survey it, which means sort of specialized survey gear, which is just an automatic level, a tripod, and a level rod. So that's the gear that needs to be acquired, and sometimes people borrow them because there's a certain amount of that gear around, or they can be purchased for about $300 for the kit. You'll need a field tape, measuring stick, ideally a thermometer to, at the very least, measure temperature, if you've got one, a water quality meter, and also safety gear. You are most culverts that we're working on assessing are on roadways, and so they need to be, so safety is a real concern, and having proper safety protocols in place when you're parking your cars and that sort of thing is a real consideration and something that needs to be considered. So here's our data sheet. As you can see, there's a lot of fields to be completed and quite a lot of information to be collected. There's some talk about doing a more rapid assessment, and that is an option. But when we do our training for our assessment training, our rationale is you're on the site, you may as well collect as much information as you can. It gives a lot more information that can be gleaned, not just about whether or not your culvert is a barrier, but also whether or not there are options to remediate or fix the fish passage, and that's kind of the ultimate goal. So when you're on site, there's a lot of things, and also as a group is trying to get to know their watershed, you might as well take some opportunity to learn some specifics about that brook in particular. So the preliminary data, and this is collecting data really requires a lot of emphasis on doing high quality data collection. It's not really valuable if people aren't careful with the data they collect and aren't specific with it. In our training sessions, a lot of data has been collected, and then people will send it in, and if there's parts of it missing, it makes it a lot harder to really analyze the data for whether there are fish passage issues and also whether or not there are remediation options. So emphasizing having really good data collection is really key. And so you need the specifics of the site, and it's important to have the geographic references so that you can find them again. Believe me, if you do a certain number of assessments, they end up all looking the same, and so you need to make sure you've got them clearly marked down in your data collection. As I said before, images are really, really important, and recording the data file, the photo files, and taking very specific pictures. It's often a problem to get photographs mixed up, or the camera's forgotten and the pictures don't get taken. And it is quite a bit harder to interpret data without those images. And when you go reading other reports from other jurisdictions, that's actually a reoccurring theme that not adequate pictures were taken. And then if there's any kind of problem with the data or interpreting it, you can always refer to the photograph and have a much better sense of what the site is like, and see if the site pictures match up with the data collected. So taking the pictures, there's 4 in particular that need to be taken, which is upstream through the inflow end, the upstream end, upstream of the top of the culvert, through the culvert, and then downstream from the outflow out, and then back up through the culvert. So I'll just give you a little example of those. So there's, from the upstream perspective, looking at the entrance to the culvert, and then down through the culvert, then looking from downstream back up to the outflow, and then through the culvert from the bottom to see, particularly as in this case, there's baffles, so you can have a better understanding of what the culvert looks like inside. There's some other images you might want to take. For example, whether or not there are any fish that you actually see, because that's always encouraging, or other issues such as, in this case, sedimentation that's coming into the brook. So anything else around the site that might be useful or of interest. Taking the stream characteristics, it's an opportunity to collect some point-in-time water quality data if you have some water quality meters with you. You get a little point in time, and it might raise some flags to whether or not further investigation needs to take place. It also gives you a sense of the type of stream you're working on, and it might be useful for prioritizing where you might put your efforts for fish passage remediation in. For example, if you determine that this stream is particularly a cold water stream, would offer cold water refuge, it may be a higher priority for fish passage restoration with a goal of improving trout populations, for example. And so you can take those measurements, and then you have a little bit of data. And again, you've got a crew on site to do the assessment, so you can collect that data while you're there. Some information about the kinds of substrate that's on the bottom, which is really just a best guess or assessment, really, of percentages of different substrate materials. It will help when it comes time for implementing remediation, what your options are based on the kind of substrate that's on site. The next part of the assessment is looking at the culvert itself. There's a lot of variations in culverts. There's every kind of culvert under the sun, and some of them are mixed media too. So in terms of culvert material, they've come in all kinds of shapes and sizes, and the material is important in part for remediation options, and then also in terms of what kinds of fish passage issues were likely to occur. The shape also makes a difference for the same reasons, and that needs to be recorded. So you can see them in different, there's different shapes, and there's sort of menu items you can choose from. And you can see these are quite different types of culverts. This regarding the open bottom arch, it's almost like a bridge, but doesn't have footings. So like a bridge does, so that gets its own category as a culvert. The entrance types is important, and so there are different entrance types we assess for. And again, and then a look at the bottom of the culvert itself, whether it has a natural bottom or an unnatural bottom, and whether there's been any of the substrate or rocks and such that have collected in the bottom of the culvert. So this is a natural bottom culvert or an open bottom culvert, or an unnatural, which is really the bottom of the culvert. Just it essentially becomes a hard bottom. The other consideration is whether or not that culvert is deformed, and so that will limit its capacity to carry flow, and also certainly in terms of any kind of remediation options. The other key thing, some culverts have baffles in them. Baffles are installed in culverts to provide fish passage, and so it's important to know whether or not they are in there. And eventually, and they can be made of various materials, and are quite useful when they're absent. Sometimes we add them in for remediation possibilities, and to know that your baffles are functioning is another consideration. We do quite a bit of habitat assessment for the top end of the culverts. Inflow habitat tells you, meaning the upstream end, will give you a sense of where the culvert is in the stream, and whether or not the culvert itself is backwatered. By backwatered, I guess people know what that means, but you sort of assess whether it's going, like there's water 1/4 of the way up it, half, or 3/4, or all the way, and that is also a part of what goes into considering whether there's fish passage some of the time, or all of the time, or none of the time. Noting whether beaver dams are present is really important. Beaver activity causes a lot of problems around culverts, and resolving that is an ongoing challenge for a lot of people. And again, whether fish were observed or not is also encouraging to know how much effort should be put into any given fish passage situation. So some of that is just noting of the situation, describing what's going on, and then there's a set of measurements that need to be taken. The measurements of the culvert itself, in terms of how big it is, the wetted width inside the culvert, and where the high water marks are, and also the corrugation in the case of metal culverts. So there's this particular set of measurements that happen just to see how big it is, and that has to do with the roughness of the culvert and as part of the calculation for fish passage. So then there's a certain amount of data that gets collected upstream of the culvert. It's important to be able to describe the upstream habitat in the culvert, to consider the culvert in situ, in the site, within the stream. So they're pretty standard field measurements for stream assessments to do with widths. And then the next is when the survey gear comes into play. I've seen some assessments where people will just sort of either have a look and guess whether a culvert is level or pretty close to level or quite steep, and it's pretty hard to do it by eye, and even with a clinometer you probably aren't going to get the accuracy you need. The guidelines, provincial guidelines, and also federal fisheries notions guidelines are for culverts to be just not more than 0.5% slope, and it's pretty hard to eyeball 0.5% slope. So a set of measurements gets taken by surveying to take a set of elevations, and there are in fact 6 of them, which I think my next slide will show. So there's 6 sites that get the 6 points that get measured. So on the upstream end, the first one is the crest of the upstream riffle, and identifying the riffles and the crests are pretty key, and we have found in our training that it's a bit of a challenge. It takes a little bit of practice for people to be able to eyeball them if they're not accustomed to doing that. So you get the crest of the upstream riffle, and then the elevation of the inflow to give the upstream slope of the brook. And then so that's the upstream survey points. And then there's the downstream survey points. So downstream of the culvert, there's a set of measurements that are done. So we try to arrange the surveying so people spend some time upstream and spend some time downstream. You're probably working with a crew of 2 people, one person on the survey on the level with the tripod above on the road, and somebody down in that culvert with their survey rod. So you don't want to have to make them jump back and forth across the road too many times. So they will check on the embeddedness of the culvert, whether or not there is material that's deposited within the culvert. For the most part, we find we don't see too much material in culverts. Velocities tend to be pretty high in culverts and blast things through, but sometimes you do get some material deposited, and that is important to note because that's where you're taking your bottom of your culvert elevation from. And so then there's a set of elevations that you're going to take. So there's the outflow flow invert, and also if there's sediment in it, that is not the bottom of the culvert, but where the bottom of the sediment is. The next one is the bottom of the pool, if any, outside the culvert. The next one is the tailwater control, which is the measurement that was going to define how much water there is at low flow conditions, and whether or not how much of an outflow drop there's going to be under low flow conditions. And the next measurement that has to be taken is when you have to go further downstream to get the crest of the second downstream riffle. These are quite challenging, so what you need to know is one is the low point in the tailwater control, and then the low point in the next riffle, just to give you your downstream slope. Once with those measurements, there's some calculations are able to be determined. One is the head of the culvert. The other is the slope of the culvert itself, and then the calculation of the outflow drop. The downstream channel slope is also calculated from these measurements. So the point of being able to take why do we want kind of the upstream stream slope taken, and why do we want the downstream streams taken? For one thing, it's in keeping with new regulations. You need to put your culverts in sites that are 0.5% slope, or if you're putting them in a steeper slope, you have to maintain the culvert at the same level as the stream, and probably put baffles in it. So it tells us quite a lot about the condition of the brook. Then the next part of our surveying is a tailwater cross section, and we meet a certain kind of resistance for taking this because it seems like a lot of extra steps. But taking the tailwater measurements in the brook, sorry about that, is important, because what that will give us is a sense of how narrow the brook is and what are the options for both remediation and how water will flow out of the culvert over time. At different water levels. So as I said, a culvert that's set on a stream that's greater than 0.5% slope, but steeper, is going to require baffles in it. So if there are baffles in the brook, in the culvert, you will need to then take the measurements for those too. So quite a lot of information gets collected, but it's pretty much running down the page, and you collect all that information without too much trouble. And you can see that those are just different types of baffles. And baffles are pretty useful, and it's great to run into them, because then you can know that the culvert, there's a better chance of fish passage in those culverts. But we've also come across culverts with beautiful baffles in them, but still have a big outflow drop into them. So they're sort of baffles to nowhere, and that without remediation of the culvert, there's never going to be fish passage in them. The other consideration is whether or not those baffles also have chutes, and that determines on how well they're going to function and if they're going to allow for fish passage in them. And baffles are a little bit, they complicate the survey in terms of adding time and effort to them, but it also then provides a better assessment. What we do with our training session, and I'm not going to get into it too much because we do a training session. There's some in classroom time, but the valuable part of the training is to actually get out and learn how to use your survey gear, and then get comfortable with it, and then be able to go on to on-site and practice being able to actually assess the survey and hit all the points. So we do spend some time with how to survey, and being able to do that right is a key part of being able to do good culvert assessments. So again, there's those this is really only the 6 survey points, but without having done the survey points, you don't really have a good assessment. You can't really do a good assessment of fish passage in your culvert. We are in the midst, we're looking forward to launching an online database in order to at least house culvert data collected in our province. Once all the data gets collected, it's important that it's valuable data, and a lot of resources has gone into collecting it, and so having a place where it can be held and is really key. It's a bit of a job. You got to make sure you input your data, but that's a whole lot better than having data sitting on field sheets or in a spreadsheet that may or may not get passed on and moved along. With the data, there's analysis that can happen in terms of determining whether culverts are barriers some of the time or all of the time, how high a priority they are for fixing, and whether or not there's remediation options. Because remediation of fish passage, whether it's replacing a culvert completely if it can't be fixed, or fixing it is the goal for what we're trying to do. I'm not going to get into this too much. It would be a different topic, but I did want to just highlight some of the options there are when you get looking at all the culverts in a watershed, and how many of them may not pass fish. It can be sort of discouraging, but what's encouraging is that quite a lot of them will, a relatively easy fix is possible. And what our program, what we've been doing the last couple of years, is to try to come up with fairly low-cost prefabricated solutions to fish passage, and so it made out of prefabricated. So whether it's metal chutes and baffles inside a culvert to allow for fish passage to make up for outflow drops, or for larger outflow drops, you can do kind of pool weir little fishways that can get installed, or simply installing baffles through long culverts is the difference between whether or not you're going to move fish whether fish can move through your water course or not. And we've been pretty encouraged. There's been about 25 of them done so far in Nova Scotia. They can't be put everywhere, but they are encouraging as a way of making some fixes, not just handing a list of bad culverts to your Department of Highways, but also having some suggestions for how to go about fixing them. Next steps in the program, we are getting pretty excited. We think there's going to be the opportunity to make this a little bit more widely available in terms of training and the materials that we've developed. The Petitcodiac Watershed Alliance is kind of leading an initiative to develop this Atlantic-wide. We're working with them, and the Clean Annapolis River Project, as a leader in Nova Scotia, is also very closely involved in that. So for those that are elsewhere in the Maritimes, you can kind of watch for that and some opportunity to do more. Get into really how to assess culverts, get the data analyzed, and then have a look at what your remediation options will be in time. So I think I've kept that pretty much on time. So thanks for listening as a sort of an introduction to the complexities and also the sort of the straightforwardness of just getting the culverts assessed. I guess I could take questions.
Thank you for that presentation, Amy. It was great. We did have probably our best showing of attendees for our seminar series or webinar series this year, 76 attendees. So that goes to show how popular the subject is and how people are actually concerned about it. It's now time to open the floor to you guys for questions and answers. So like I said, there are two options. You can either type in a question and I'll read it out, or what makes the question period actually a lot more enjoyable is when people raise their virtual hand, I'll unmute you and you can actually ask the question to Amy rather than me saying it aloud. So yeah, we do have a question that came from Jackie Bourgeois at the beginning of your talk when you were talking about your data sheet. And the question is, does the data sheet come in a format that can be uploaded into a Trimble data unit?
No, it doesn't. There has been some, I mean, not that it couldn't be, I guess, as far as I understand with Trimble's, it was just a matter of putting the putting the questions into it, like developing the questionnaire. I'm not super familiar with Trimble's. It can be done, and I know DFO has some Trimble's that's got a version of a culvert assessment in it, but they're maybe not quite as detailed as what we like to do. Yeah, so it could be done. We have also thought about trying to put them in a tablet, so you're just entering the data directly, and that might be a way to go. Right now, we're still sort of pen and paper, so that I guess at least if you drop your paper, it only gets wet. So.
All right. Carol Ann Gillis has a question, and it's, once you've gathered all the data, what model do you apply to assess passability? Kaufman?
What was the last word? I'm sorry.
Kaufman? It's
Kaufman?
less possibility, that's the question. And then Kaufman, I'm assuming, is a method.
We have a prioritization, and it's sort of mostly based on it's kind of based on slope, on outflow drop, on the stream to culvert to stream ratio, and hang on. I didn't really get into that part of it too much, did I? And also culvert length is the other big consideration. So it's sort of, they're kind of indicators of the conditions, as opposed to doing a more complex analysis like using fish crossing or other things. We pretty much, it's pretty straightforward that way.
The next question comes from Paul McNeil, and his question is, does the 2016 database come with standardization of how naming and other identification of culverts is made?
Yes, it does, and I probably should have talked about that a little bit more at the beginning. So there is a part of the training that we do is to help people sort of plan out where they're going to do their culvert assessments, and also how they're going to name them and whether or not, and so to give some thought. Like every group can, we don't really prescribe you must do it exactly this way. It needs to be something that's useful for the group and something they can follow, but we do have sort of a set of suggestions for naming it by water course and number. Because it is important to keep track of where they are, not just, and also so the name has some relevance and meaning, and you don't only have to refer to your geographic coordinates to be able to find it, right? You can know that it's on such and such brook just based on the name of the culvert. Yes.
Okay. So both Aaron Shaw and Michelle Letourneau have questions about whether or not the protocol and the data collection sheets are available online, or if they are able to get a copy of them.
Yes, we do make those available, and they should be online. We're a little bit experiencing some difficulty with their website, actually, but we're looking forward to getting also the database online and being able to do the full launch for those available. So right now they only end up kind of getting sent out as people ask, and people can get in touch with that contact information there too.
Okay, thank you. And Rick Simpson has a question about whether or not what is the progress of Nova Scotia's funding using this methodology and results obtained to date, and future plans and budgets for this essential work, particularly for fish passage benefits.
So the question was, what kind of funding is available?
Yeah, like the provincial funding, the progress of Nova Scotia's provincial funding using this methodology and results obtained to date. Are there future plans and budgets for this essential work in provincial level, or I think that's what he's trying to get across.
Right. Not that I know of. So Nova Scotia Dam Association is a non-government organization, and so we've just been kind of working away at this with community group partners. We've had some acceptance of the methods when we were developing protocols. Sort of, we have them to agree with current guidelines. I wouldn't say there's a big movement afoot to do this in a big way. There's thousands of culverts, and I guess people are a bit reluctant to get on the hook for all of that. So I wouldn't say that that's totally a move. That being said, there is interest for the Department of Highways. They do have a priority. They do make a priority list, and it helps if, for my experience, is like kind of the squeaky wheel gets the grease if the culverts have been assessed, and you can bring it to them and say, this is a fish passage problem and it's important it gets fixed. Either it's on the agenda for if roads are getting maintained, before. We've also had quite a lot of discussion and buy-in from Department of Transportation and Infrastructure Renewal here in Nova Scotia to work collaboratively with their bridge maintenance crews. So just if I go back a bit, this project here was on a brook in the valley, and we had a lot of help from the bridge crew in installing that, and they had good suggestions for some design modifications. And so what's encouraging is that then the people actually involved get to see that those get to see how we can remediate them and how they can do it. And they've done some other ones that we've proposed and done some design for. So there is interest in solving those things. They don't like to see their culverts not passing fish either. And so for the ones that can just have some remediation versus the expense of ripping up, all the asphalt and everything, that's great. We can't do it everywhere, but in some of them they can just be fixed with that. So I don't know if there's a full province-wide program, but step by step you can kind of get a little bit more momentum with it.
Zian Sally has a question, and it's recognizing that velocities and water depths are important factors. Ideally, when should the assessments be conducted? At high flow or low flow, or both? And should the culverts be designed to allow fish crossing at high flow or low flow, or both?
Well, that's a good question. The assessment is designed that you can do it regardless of the flow, because what it does is is with the survey is it assesses the residual pool level, so you know how much how much the water depth would be at low flow in terms of an outflow drop. And at high flow, you can calculate the size of the culvert versus the amount of water you'd expect in the given watershed and whether or not it's oversized. It is harder to do the assessments at high flow, but if you do it and like a lot of culverts are partial barriers, so the analysis sort of calculates that out so that you're going to pass some fish some of the time, and whether or not fish are able to migrate. They may not be able to migrate through the culvert all the time, but chances are if the culvert is passable at moderate flows, the fish probably aren't moving at low flow either. So when you do the assessment is not critical, other than the facility of being able to do the assessment itself.
And we have two questions from Leanna Rice. Her first question is, have you thought about using an app? It could be used in the field and the data could be automatically updated to your database.
Yeah, we thought about that. Well, we haven't done it yet, but that's an opportunity for something that could go with it, and I think people would like to use it. It would be especially useful. Like you'd want to probably easier to work with either on a phone, or even on a tablet. And so, yeah, there's a lot of opportunity for it to go that way too.
Yeah, and her follow-up question or comment is, if this app project is made public, then general members of the public could report problems with the culverts, for example, blockages and...
Well, that's it. If people can actually do there's all kinds of opportunities to do it. If people, just members of the public, identify a problem culvert, as you say, like with a blockage or a big outflow drop, and they mark it, then, if a group is working in that area, it's an area of their interest, then they can go ahead and do an assessment of that and figure out what can or might be able to be done. So yeah, there's so much opportunity to do that.
And that is all the questions I have right now. If anyone else has any questions, this is kind of your last call for questions for Amy. I think that might be, we got one more. Pascal Goslin is asking, who is responsible for repairing the culverts?
For paying for the culverts?
Repairing, paying.
Or repairing them? Well, that's a really good question too. because, of course, the culverts are technically owned by somebody. Many culverts are on public right-of-ways, but sometimes they are on private roads. And so technically, the owner of the culvert should be responsible for repairing them, and or for paying for them to be repaired. And they are sort of, for the most part, legally responsible to maintain fish passage. And it's partly a question of scale when you're talking about thousands of culverts and people don't. So it's the owner who should pay for them, who doesn't. And then, so we have actually kind of struggled with that somewhat, especially if we're doing remediation on publicly owned Department of Highways culverts, whether or not it should be community groups doing that or not. And where we can, we try to get partnership with them, and it's sort of a question of whether we just wait for somebody to pay for it or to get it done or get that repaired itself. And it's kind of the age-old question with a lot of environmental work, whether you wait for the person who should pay for it to do it, or whether the repair should just happen. So it is something we still kind of struggle with as and ideally, if there's some more interest and options for governments, it is really primarily public highways. Sometimes in some areas it's also forestry companies that have culverts that are problematic, and that's a good opportunity for partnership. They often people are willing even to pay for it if they would just know what to do, and somebody else could make it happen. So I think being kind of optimistic about how interested people are in it is a good approach to take to it, because the more information people have, the easier we make it for people to do the right thing, the more likely it is to happen.
Mm-hmm. Very good. I think that is it for now. Once again, I'd like to thank you, Amy, for giving this webinar. It was great, very informative, and I'd like to thank the participants again for joining us. This is the last webinar of this season. We are taking the summer off, and we'll start up again in the fall. We do appreciate input from our clientele and from our viewers. So if anyone has any suggestions for future webinar presenters, just email the Atlantic Salmon Conservation Fund or us here at CRI, and we will definitely take your suggestions into consideration when we're figuring out next year's schedule. So thank you again, Amy, and thank you everyone for joining us, and looking forward to working and seeing everyone next year with our fall seminar series.
Great, thank you.